Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will see what is circle theorem, and with respect to that, we will solve few questions. Now, I would like to tell you here that when you're solving circle theorems, you just need to remember few rules. So take it as a game that which rule you will apply to solve the question. Okay, so do not think that you are solving a complicated maths equation or something like that. So first of all, I will go through the rules one by one, and if you want to make a note of it in your notebook, then you will put the video on pause, right? Because when I will show you the question, these 7 rules or 7-8 rules, they will apply there, okay? And you have to read them again and again so that you can think of them one after the other, okay, which one will fit to solve the question. So this is rule number 1, which is called radius is perpendicular to the tangent. Now you can see this green line is a radius. Let me see here. So this green line is a radius and this red line is your tangent. Okay. So where they meet at the point of contact, they make 90 degree. In the question, either it is given or not, you will always remember radius and tangent always make 90 degree, because question says write the reason. So you have to remember these reasons which I have written here in pink. Radius is perpendicular to the tangent. Rule number 1. Number 2. Now if you can see, I'm talking about this rule now. You can see the red line is a radius and green line is a chord. Now chord is what? The line which join 2 points on the circumference, right? It is called a chord. Similarly, if you see, if I draw the line from here passing through the center to the other end of the circumference, then this is a special chord. What is the name of it? Diameter. Okay. So anyway, coming back to this rule. So if you look at this green line is touching 2 points on the circumference, and red line, which is radius, is passing through it at this point, and it is perpendicular to it. So if radius is perpendicular to the chord, green line is chord, then it bisects the chord into 2 equal parts, like it is written here. And this is called perpendicular distance from a point to the chord bisect the chord. Okay, perpendicular distance from a point to the chord, from the center of a point to the chord, is bisecting the chord. Rule number 3. Angle in the same segment. Now what does it mean? So let me take here this one. If you look at this chord, which is from here till here, right? This chord is making 2 angles on the circumference. I'm taking this point first. I'm calling it 1, calling it 2, just for the sake of reference. From 1, I'm making a line here on this point. Let me call it point 3. And then from other end of the chord, which is 2, I am making another straight line to the point 3. So both these lines, which are going from 1 and 2 to the point 3, are making angle x. From the same end of the arc length, which is 1 and 2, I make another straight line on the circumference. Let me call it point 4. Okay. So this is also equal to this angle. If this is 15 degree, then this is also 15 degree, because they both are made by the same arc length, or you can say by the same chord. Okay, straight lines going there. So this is called angle in the same segment. So let me explain it here. Suppose this is my circle, and suppose this is my arc length, only this much, from this end to this end, or you can say chord. Choice is yours. You want to call it arc length or you want to call it chord. From the end of it, if you draw one angle on the circumference here and somewhere here on the other circumference by straight line, then these angles are equal, and it is called angle in the same segment. So if it is written x and it is written 20, it means x is equals to 20 degree. Okay. Now let's see this property. Angle at the center is twice the angle at the circumference. Again, let me take this arc length here. It's not very perfect, but just trying to explain to you. Okay? So I can take this chord. Let me call the name 1 and 2. From this end of the chord, I am making one angle on the circumference at 0.3. You can see the straight line is going from here to here, and it is going from 0.1 to 0.3 and making angle x here. From the same end of the arc, which is 1 and 2, I am making angle at the center of the circle. You can notice this, right? So this angle which is made at the center will be double of the angle made at the circumference. So if this is 40, then this will be 80. You get my point? So this is called angle at the center is twice angle at the circumference. Let's see this property. I'm repeating. If you want to put a video on pause and want to note down these properties, you have to, because you should know this by heart when you are solving circle theorem questions. Angle in a semicircle. Now look at the diameter. Let me call it 1 and 2. Okay, so diameter is here. Now this end of the diameter is making angle on the circumference, which is represented by different colors. I'm calling it 3, calling it 4, calling it 5. Okay, these endpoints. These are coming straight away from point 1 and point 2. So diameter is making angle on the circumference. If nothing is mentioned here, it is understood it is 90 degree. Okay. Similarly here, because green line, if you see, from 2 it is going on the circumference, from 1 it is going on the circumference. So it is 90 degree. That's why it is called angle in a semicircle. For example, if I have a circle here and I take this diameter. So from the ends of the diameter, if I make an angle on the circumference, straight line, it will be 90 degree. Okay. Now let's see, very important property, another. Tangents, you know what tangents are. The line AB and line BC are tangent from the external point B. Tangents from the external point to the curve are equal in length. If you see, suppose this point is B and I draw one tangent till A and draw another tangent till C, then BA and BC are equal in length. This is the property here. Okay, one property more. Let me explain from here only. If I draw a straight line from this external point to the center of the circle, okay, it will bisect these angles. If this is, for example, 20 and this is x, then x is equals to 20. Remember it. Similarly, from the center to the tangent, it will be 90 degree. I have just shown you property number 1. From here to here also it will be 90 degree. This angle will also be bisected. So if this is 20, this is 90, then what is this? 70, right? Similarly, this will also be 70. So you will remember these properties. Let's see this. Angles in the alternate segment. This is where students usually make mistake. Let me try to explain you from here. Suppose I take a tangent here. And from the point of tangent, I draw one chord. Then angle made between the chord and the tangent. Okay, this is my chord, this is my tangent. Angle between chord and tangent will be equal to the angle which is made by the chord on the other side on the circumference. Okay, so this angle will be equal to this angle. So in this diagram, if you see, x is equals to x. Why? What is the reason? Reason is, let me choose some other color. Reason is, if you look at this tangent and if you look at this chord, so tangent and chord are making angle here. The same chord, the ends of it, are making angle here on the circumference. Yes or no? So that's why angle between chord and tangent is equal to the angle made by the chord on this other side. So this is angle in the alternate segment. Same is the case with y. If you notice here, this angle is between this chord and this tangent, right? This is also a chord, na? Same chord, if make angle on the circumference here, then this angle is equal to this angle. Okay. Now last property, opposite angle in the cyclic quadrilateral are supplementary. So if a quadrilateral is cyclic, then opposite angles will be supplementary. And one more property, that all the 4 points of the quadrilateral will be on the circumference of the circle. So if I draw a circle here, it's not very perfect. Just imagine it is a circle. And if I draw any quadrilateral inside, such that all the points are on the circumference, then it is a cyclic quadrilateral and all the opposite angles will be equals to 180. So I can say A plus B equals to 180 degree. Okay. Similarly, this angle and this angle, sum of this will also be equal to 180. So opposite angles in the cyclic quadrilateral are supplementary. Let's see the questions now. They're past paper questions. I have started with very simple one, then I will move on to the complicated ones. Which property do you think will apply here to find the value of x? And it is just 1 mark question. I'll give you thinking time. Okay. So property which is saying angle at the center is twice angle at the circumference. Why? Just look at this arc. Okay. Look at this arc. This arc is making angle at the circumference. Okay. Sorry, at the center. And the same end of the arc length are making angle on the circumference. So that's why x is equals to half of angle made at the center. So I can say x is equals to 108 divided by 2, which is 54. And reason he's saying, if he asks what is the reason, you will write angle at the center is twice angle at the circumference. See this one. What is the value of y here? Can you think of? Okay, so now again, look at this arc length. Okay. This arc length, let me call it 1 and 2. They are making 2 angles at the circumference. One here, okay, and one here. And the angle should be by the straight line. Okay. So if I draw a straight line from here, it's like this. And from 2, it is like this. Similarly, if I draw it to this side, from 1 to 4, it is here. And then from here to here. So if this is 62, this is also 62. Make sense? So nothing to do at the moment for 49, but just telling you okay, what y will be. Y will be 62. And what is the reason? Angle in the same segment.